Hi, I'm Peter Downhauer with the Community Solutions Initiative. Today I'm going to show you how to build the LightStick, which is a simple, affordable flashlight, LED-based flashlight that uses only 1/5 of a watt. The components are very affordable and easy to put together, and it runs on rechargeable nickel metal hydride batteries. As you can see, the LightStick is based on a 1/2-inch PVC Schedule 40 white pipe. We use a penny as a switch, and it has 5 LEDs which each draw about 10 milliamps with this current configuration. The first step in the process is machining the PVC pipe. So let's get started. So from one end of the PVC pipe, I'm going to make a mark at 13 inches and a quarter. I've got the PVC pipe in the bench clamp. You can also use a bench vise if that's what you have. I'll get it started on that mark by going really slowly, and then I can complete the cut with the hacksaw. From one end, I mark 8 1/4 inches. And now, I'm going to continue that arc about 180 degrees along the outer dimension of the PVC pipe. As an option, it may be useful to draw a line from the edge of the arc that you've just marked to the end of the pipe to mark where the shoulder is going to be cut out. First, we'll cut the 180 degree arc shoulder. You get it started, nice and easy, and then we just go easy and make sure we're only cutting 180 degrees. It's important here not to cut more than 180 degrees or the PVC pipe might be a little thin. I'm going to cut out the 5-inch shoulder where the LEDs are placed. I'll get it started. I'm going to cut it roughly 180 degrees. It's good to go slow on this because it's easy to get off center. And I just follow that line all the way down. In my other hand, I'm adding a little extra stability closer to the blade, and I move that down as the blade gets closer. I need to finish up the cut on the other end of the shoulder. So I've extended the line from the edge of the shoulder and I've offset it about 1/4 of an inch. And what I want to do is make a mark on that offset line 575 thousandths in and at 1 inch. And this is where the posts for the switch are going to go. Now we're going to drill these holes out with a number 29 bit, which is 136 thousandths. It's really important that we get the axes right. If we don't, then either it's going to be off kilter this way or it's going to be off kilter this way, and we're going to have problems with our switch. So I go nice and slow to get it started. Once I get through the first hole, I'm going to go ahead and look on the inside to make sure I'm still aligned on that axis and finish the drill. Now for this hole, which is the furthest from the shoulder, we really got to make sure that we get this one straight, because the spring is going to be rubbing up against it, making the connection with the switch and the batteries. Now if we flip this over, you can see how good we did. That's pretty good. Here you can see two light sticks that were produced in the training phase of building light sticks. And this one you can see is pretty far spaced apart. And that's because I was off axis on this one. And I had to re-drill that, in fact. And this one is a bit too close. And the problem is that when you put the nuts on, they have a tendency to get pretty close together, and you don't want those touching, or else you'll be always connected and therefore always on. Now we're going to drill out the LED holes, and along the center line on the inside of this shoulder we're going to mark at 1/2 inch, 1.5, 2.5, 3.5, 4.5, and then 1/10 inch back from those marks, which is where the LED terminals will go through. And then we're going to use a number 60 drill bit with a Dremel, or you can use an Archimedes screwdriver, and drill those out. With this drill bit you want to be careful not to side load it, or it's pretty fragile. So as you can see, the PVC pipe now is pretty messy, and we're going to use the deburring tool just to pull off that extra PVC material. Just go along the edges. All the edges that were cut. So, clean it out with your fingers. Get in the shoulder, around the shoulder, and then in the holes that you drilled out, you can stick the deburring tool in there, spin it around a little bit. Both sides, and then the end. I like to do the inside and the outside, but not pull too much off the outside, because it does need to connect with the copper pipe goes around it, so you don't want it too thin. And you take a look on the inside, make sure that everything's pretty much out of there. And then lastly, you want to take some isopropyl and a rag and just clean it off. And you can just do the whole outside and along the inside that you can see. We're going to be putting copper tape on there, so we need it to be nice and clean so the tape sticks. There we go. Now we need to machine the copper. We need to mark out 7/10 inch on this 1/2 inch copper pipe. Using our 3/4 inch copper pipe cutter, we'll tighten it around the spot where we marked and twist until the pipe's cut. I've made a mark about 175 thousandths in from the end of the copper, and I'm going to drill a hole with my number 29 drill bit all the way through. Take a look. Now I'll use my sheet metal shears to make a cut in between the two holes I just drilled. And if you get a bend in it, like this, you can fix it really quick, bend it back with your pliers. Now we want to deburr the copper pipe by using our deburring tool. We just go along all the edges several times until we get the edge off. When you're cutting it with the pipe cutter, it has a tendency to create a fine edge that is sharp. You could cut your finger, or more likely cut the copper tape. That is the connection between the copper pipe and the LEDs. I also want to make sure that we go through these drilled holes and deburr them, because we're going to be putting a brass screw through that, and we need it to slip easily in and out. Now we've got it deburred. This part is done. Now we need to machine the penny. I use my heavier pliers to hold on to it, and I use a number 27 drill bit, and I want to offset it about 1/1500ths of an inch in. Doesn't have to be exact, but it shouldn't be too far off. Now we want to build the first switch assembly, which is the long screw. We're going to be using a 2-inch screw, a smaller diameter spring, our penny that we machined, a washer, 2 of the undersized 632 nuts, 2 more of the regular size 632 nuts, and a nylon acorn nut. First I'll cut off about 1/2 inch of the spring stock I have. And go retrieve it. I'll place that first onto the 2-inch screw. Just bring it all the way up to the top. There we go. I'll put the washer on, and then the penny. The washer just helps keep the penny flat as it's used as a switch. And then I'll screw on my 2 undersized 632 screws. There we go. Now what I want to do is take the PVC that I put together so far and place it through there and get an idea of how much is sticking out. Since we're going to be putting 2 of these nuts and the acorn nut on the other side, or 1 of these nuts and the acorn nut on the other side, we'll need to cut this screw back just a slight bit. We'll use our machine screw cutter. Just screw that in, and it shears it off. So you want to make sure that you don't shear off too much. Just screw it through. Put some pressure on it. There we go. And unscrew it. Sometimes it helps to use a screwdriver. There we go. Now after you shear that off, sometimes this cut part of the screw is a little bit, it hangs up on the nut, so we'll give it a test to see if you can actually get that on there and if it actually threads. And if it doesn't easily, what you want to use is a file or some sandpaper and keep it at about a 45-degree angle and twist the screw around. And what this does is it shaves off, or sands off, the part of the thread that's not straight. Think you've got it, test it again. There it goes, it starts getting a thread. And with only a minor amount of frustration, this will work. Like so. Once we've got that, we can take the PVC that we've been working with, the LightStick base, stick that through, make sure these are all, the undersized nuts are all screwed all the way up. Stick that through, like so. Take one of our larger nuts, screw that on, and follow that up with the acorn nut. And make everything nice and tight. Then you can take your screwdriver and just tighten up the top a little bit. And I'm holding the bottom acorn nut right when it gets kind of tough, so you know this penny's on there nice and tight. Now we're going to apply the copper tape. What we want to do is cut about a 13-inch length of this copper tape, and it's going to sit on the left hand side of the LED center line from this orientation, and it's going to sit about 1/8 of an inch to 1/4 of an inch off the edge of the shoulder that we cut out. So I'll just mark it there, cut it with my scissors. Peel off the backing. And apply it, as I said, about 1/8 of an inch to 1/4 of an inch off the shoulder. All the way to the end. Now if it overhangs a little bit, that's good. You want it to overhang that and just bend it over the lip, and then just firmly push it down all the way. There we go. Now let's do the other side. This is a shorter piece. Basically we want it to be about 1/2 inch from that hole, and it's going to go to the end, so that's about 5 inches total. Remove the backing again. Start from this side. Also about 1/8 of an inch to 1/4 of an inch from the edge. There we go. Press it firmly down. You can see now it's about a half of an inch from this hole. Now we're going to be putting together the second screw assembly, which has the 13 ohm resistor. We're going to be using a 1 1/4" 632 brass machine screw, small washer, an undersized 632 nut, and a regular size 632 nut, and the nylon acorn nut. And we'll start by wrapping the resistor around the screw. So, we'll put our washer on and screw on the undersized nut. We'll tighten it up a little bit. There we are. And we can put it in place. We'll want the resistor on the same side as the penny. On the other side, onto the screw, we're going to put the regular size nut. Tighten that, and then follow with the acorn nut. Finally, we'll take our screwdriver, holding the back end, just give it a tighten it up a little bit. You can always rearrange the resistor. Okay, now we're ready to put the LEDs in. Here's a close-up of the LEDs that we'll be using. They're 3mm LEDs, which refers to the size of the bulb. And you can see that all LEDs will have 2 legs sticking out. One of the legs is longer than the other. That's called the anode. And if you look inside the bulb itself, you'll see that it does not have a flag, whereas the shorter leg, the cathode, does have a flag. That's the negative side. So when we put this into the light stick, we'll need to be sure to bend the anode, the longer leg, towards the longer copper tape. Now we're going to insert the LEDs into the light stick base frame. We'll just put the long end in first, and the important thing is just to try and stay consistent. And then the long end is going to be wrapped around the side of the copper. That's the long side of the copper, and the short end is wrapped around the short end of the copper. I just wrap that right around the edge and into the channel. I'll do that for all these LEDs. I want to try to avoid having extra material of the terminal on the other end. So just make sure you press that down nice and firmly when you bend it over. There we are. Now I'll take my end clippers and just cut off any excess of the LED terminals. Go back with the stubby pliers just to make sure that it's on there tight again. Alright, now I'm ready for soldering. Now we're back at the soldering station, and we'll just put a little solder on those connections. You really just feed the solder in, make sure you get a little solder on either side. try to avoid adding too much heat. The last one is the resistor, and since it's not held down on this side, I get a little bit of solder on it, and then I take my pliers, put a tiny bit of pressure on it, heat up the solder again, and then it gets pushed down, and it cools off in a matter of seconds. I'll do the other side. And I'll show you a close-up of the solder of the last one. Now we need to attach the copper pipe to the light stick, and you can see this one. Basically what you do is you bend the pipe over the PVC and then you use tape to actually attach it. So here's our machined copper pipe, and the way I do it is I just use my pointer fingers, get in there, and I want to put the cut part of the copper pipe opposite of the copper tape. So I bend it over, and it's very easy to rip the copper tape, so you want to be careful on this operation here. There we go. And now we've gotten the holes about, if you can see that, about 1/8 of an inch off the PVC pipe, so that the brass screw can go through there. Now we're going to mark the positive side by putting a big red plus on the end near the copper pipe, on either side of the copper tape. And we're going to take about 6 to 7 inches of 3M 375 packing tape, and we're going to attach the copper pipe to the PVC pipe. I start on this side of the sheared part of the copper, and as I go over the first time, I'm actually squeezing it to make sure it's on there nice and tight, and then I start to go around. And because the diameter of the copper is bigger than the diameter of the PVC alone, the tape will have a tendency to bunch up a little bit on the PVC side. Now that we've got it attached, if you've got a little bit of the tape over the holes, you'll need to clean that up so that you can easily put a screw through there. Now we need to put together the spacer, which uses a 1/4 inch spring, and it's about 1 1/4 inch to 1 1/2 inch long. And you can see that when all the batteries are in the circuit, the spring is actually going to be connecting to the post and then to the negative, positive, negative, positive, negative, positive terminals of the batteries, and that's how you make the circuit. So one thing about this spacer is it's actually a little bit too narrow, so we need to increase the diameter, the outer dimension of it, by adding our 375 3M packing tape. And we'll take about 20 inches of that, and I'll show you how that's done. We need about 20 inches of tape, and I just eyeball it. If it's a little more or a little less, it's not too much of a problem. If it's too much, then it's going to be too wide to actually fit in that hole, so you want to make sure you don't do too much. Then I place the spacer in the center of the tape, and I start rolling. And if you have a little bubble in there, that's no good. You need to go back and redo it. It should be nice and smooth. And you can see even now as I roll it, it starts to get a little off center. When it gets off the edge of the tape, I just take my razor, cut it, and place it back in the center and continue rolling. I roll that all the way to the end, and now I need to cut off the excess tape. So I'll bring it down to my cutting board here, and with the razor pointed away from your fingers, Onto the cutting board, I'll just go around the edge. Both sides. And now I take the spring that I already put together, I already cut, put it in there, and just as an example I can drop it in there. Now we're going to use our 375 tape as a protective covering. I'll pull out just enough for the length of the light stick. And on the long end of the copper tape, I'll get it started. And I'll just push down one edge. And I'll take my light stick sticker, put it in there. And get it going, get it started even more. Take my scissors and make a cutout for the switch on either side. And I can press the tape firmly down on the back, and then on the front I can press that firmly down. It'll overhang a bit in over the shoulder. And then I'll follow up with my razor. Cut off this excess flap, and I need to clean up here on the edge of the shoulder. I'll just take my razor along the edge of the shoulder here. Don't put too much pressure as you're going over the LED terminals. And pull that off. Finally, I'll go over all of it and make sure everything's firmly down. Just put your finger over everything. There we go, we're almost there. Now we'll take a bit of 1/2 inch extruded polyfoam rod and cut off about a 1/2 inch. And this is going to go inside the start of the shoulder. We just place it right in there, and that's going to just protect the insides a little bit. We can put our spacer in at this point, and some batteries. When we put the batteries in, we want to put the negative end in first, all the way down. This is just for a test. We take a 1-inch brass screw, push down the end of the batteries, and go through both ends of the copper pipe. And then we can test our switch to make sure that we get light.